Namaste, dear students. Today we are going to discuss about atomic structure and chemical bond, which is under Unit 14 of Science and Technology, Class 9. As we discussed about other things in our previous classes, we are talking about atomic structure. At first, I would like to request you all to think about what could be the smallest part of the substance. What is the smallest part of the substance called? Please, would you mind to think sometime? Yeah, as you are thinking, there are many things, millions of substances over the universe. So, out of these millions of substances, these are called the components of the things made through which they are made up of the different elements, and these elements have got some atoms. Some of the elements are diatomic, some of the elements are monoatomic, like oxygen. Oxygen has got two atoms. That means oxygen has two smaller components, they are the atoms, as well as iron, as well as other metals. They can be represented by single molecular structure like Fe is for the representation of iron, as well as copper is represented by Cu, which is called the monoatomic. So, in fact, what is atom? We are going to talk about atom in our class today. So, the smallest particle of the substance which can take part in chemical reaction is called atom. So, the as you have talked in your previous classes that the reactions can be taken place by different substances as well as different chemicals. So, while taking the reactions, while taking part in the chemical reactions, the atoms of the substances are taking part. So, the smallest part which can take part in chemical reactions, they are called the atoms. So, we do have got some knowledge about the atoms. So, atom, that means atom is the smallest part, is I have just talked about it. So, what is the size of atom? We have to talk about this. So, as you know, there are if there is a spherical substance as well as the circular substance, this circular as well as the spherical substance has got diameter as well as radius. So, atom has the spherical shape. So, if it is considered as a sphere, then it has got the diameter 10 to the power minus 10 meter. So, it consists of many smaller particles, they are called subatomic particles, which are proton, electron as well as the neutron. So, proton and neutron, they lie at the center. So, they are considered as the nucleus, and electrons are just revolving around the nucleus. So, as we used to write the atomic structure, first proton as well as neutron, they are at the nucleus, as well as electrons are revolving around the nucleus. So, this path followed by the electrons, that is called orbit as well as the energy level, and the sum of proton as well as the neutron, that is called the nucleus. So, as you are looking in the screen that if you are taking a substance and it consists the compound, as well as compound consists of elements. Compounds may be either of monoatomic as well as diatomic and so on, and elements consist atoms, and inside the atom there are three subatomic particles, they are called proton, electron as well as the neutron. Yeah, as I have just talked about the as well as I have just drawn the figure over the screen, over my whiteboard, that proton as well as neutron lies at the nucleus, as well as electron is being revolved around the nucleus. As you are looking, there is a solar system. So, as the planets revolve around the sun in solar system, in the atom also electrons are just revolving around the nucleus. So, nucleus we can just consider that the atomic structure like that of the solar system. So, you can just see in the screen that proton as well as neutron, they are just at the nucleus, they are just turmoiling it inside the nucleus, and electrons are being revolved around. So, as we can just compare the solar system as well as the atomic structure. So, to conclude this point, proton as well as neutrons, they lie at the nucleus and electrons are being revolved around out of the or out of the nucleus, and this path followed by the electrons are called the energy level, or it is also considered as the orbits. So, you can just you can see the structure, you can see the structure of carbon, that there are 6 electrons are being revolved around over the nucleus, and it has got 6 electrons. So, total number of electrons present over the carbon atom is 6, and if you count the total number of proton as well as neutron at the nucleus, you can also see there are altogether 6 proton as well as 6 neutrons. They are being just compiled, just found at the center of the atom. As well as in the second figure, that just you are looking, there are 2 green balls at the center as well as 2 red balls at the nucleus. They are the protons as well as the neutrons, and 2 electrons are being revolved around the nucleus. So, it is all about the nature of the atom. And in every atoms, all of the electrons are being just distributed over the different orbits, as well as proton as well as and the neutron are just found at the center of the atom. So, such type of atoms are of the smallest particles, they can just take part in chemical reactions. So, while doing the chemical reaction, these atoms take part. So, there are 92 natural elements. They can be classified into such periodic tables, because to make our studies as well as to make our learning more convenient, the periodic table has been constructed. So, just you can see there are 92 natural elements as well as altogether 118 elements. So, out of them, rest of the 92 elements, they are the artificial, which are man-made as well as the human synthesized elements. So, these elements have been denoted by such atoms. So, they have been represented symbolically, like hydrogen is represented by H, as well as helium is represented by He, and lithium, beryllium, and so on. So, this is in fact the periodic table in which elements have been represented in different atomic forms. As we are talking about the atoms, as I have just talked about, there are 3 types of subatomic particles. They are proton, electron, as well as a neutron. So, they are the location where do we find the subatomic particles like proton, electron, as well as neutron. So, as you are looking in the figure, that green balls represent the electron, they are just out of the nucleus, as well as red balls represent the neutron, as well as blue balls represent the protons. Protons as well as neutrons, they are looking at the center, as well as the collection of proton as well as the neutron, that is called the nucleus. Just it has been drawn as a the spherical diagram there, you can just see. So, by talking about this, I think you are able to know the location of different subatomic particles, like where does electron lie, as well as where does neutron lie, and where does proton lie, and what is collective form of the proton as well as the neutron. I think it is quite clear about this. Moreover, it can be represented by like this, because do all of these orbits have got the similar path? No, they can be just they can have got the different types of the paths. As you are looking there, that it has got the path like this is the path followed by the one type of the electrons, as well as this is the path followed by the another electron, and this is the path followed by the another one, and collectively it has, you can just see there are proton as well as neutron at the nucleus. So, even we used to denote, we used to write the atomic structure like this, but practically as well as in if we want to denote such type of atomic structure in 3D plane, we can just represent in this way. That means some of the electrons are being revolving around through this way, as well as some of the electrons are being revolved around through this way, as well as some of the electrons are being revolved around through this way. So, this is all about the position of the subatomic particles as well as the collective form of the proton as well as neutron. They are just called the nucleus. Just we can learn about the subatomic particles over there. Now, as we have just discussed that the electrons are being revolved around the nucleus. So, the path followed by the electron while revolving down the nucleus, they are called the orbits, and in other words they are also known as the energy levels. There are various types of the energy levels found over the atom. So, some of the electrons are being revolved around in the inner side towards the nucleus, some of the electrons are being revolved around a bit outer side from the nucleus, and some of the electrons are away from the nucleus in fact. So, when we move from nucleus to away, then we will find some type of the energy levels like the first energy level, that means which is nearest towards the nucleus, that is called K shell. Actually, the second one is as you can see in the screen that K shell has this is the first cell which is being found over the nucleus, and this is the second cell that is called L shell, and it is found at the second cell of this atom. As well as you can see there is the third cell. So, you are just looking here, it is the third cell because this is the third outermost layer from the nucleus, and this is the fourth cell that is called N cell, which is found fourth position from the nucleus. So, they are the different types of the energy levels which have got the path that are being followed by the electrons. So, they are also known as orbits or energy levels, as you are just looking over the first sentence over the screen. Now, how do we allocate, because you are just looking 2 electrons at the first orbit here, and you are looking 8 electrons as well as 18 electrons and 32 and so on. So, how do we distribute such type of electrons in different types of such energy levels? As just you can see, and we have got a theory as well as we have got a formula to distribute these electrons in different types of such energy levels or in such orbits. So, that is called the electronic configuration. We are just going to configure the electrons in different types of the orbits. As we are talking about the electronic configuration right now, that is the number of electrons that are going to be distributed in different orbits, that is called the electronic configuration. So, electronic configuration can be done by the formula that 2n square, where n represents the number of orbits. If you are talking about the electrons to be accommodated in the first cell, then you have to write the value of n is 1, as well as if you are talking about the number of electrons to be accommodated at the second cell, then you can write the value of n equals to 2. So, if you want to calculate the number of electrons to be accommodated in the first cell, that is K cell, then you can calculate like this. So, for K cell we are going to use the formula 2n square, where is I have just told you that if you are talking about the K cell, then we have to put the value of n equals to 1, that is 2 into 1 square is equals to 2 into 1 equals to 2 electrons. So, at the first cell that is K cell consists 2 electrons. You can just see over this stocker that is K cell has given 2. So, it means it is due to the formula 2n square. By the same way, we can calculate the total number of electrons to be accommodated at the second cell, that is L cell. So, for the L cell, we have to put the value of n equals to 2. So, we can calculate like this: L is equals to 2n square. In this condition, we are going to put the value of n equals to 2, that is 2 into 2 square is equals to 2 into 4 is equals to 8 electrons. So, at the second cell, there will be total number of electrons 8, as you are just looking over there. So, by the same way, if you are going to calculate the total number of electrons to be accommodated in the N cell as well as M cell, then will be the same. So, this is the method to allocate the total number of electrons in the different energy levels, that is different orbits. So, if you use the same type of formula for the third cell, that is M cell, you can put value of n equals to 3, and for the fourth cell, that is N cell, you can put the value 4, 2 up, then you will get 18 as well as 32 respectively. So, this is all about the electronic configuration, and it can be represented by like this. We are just talking about here. And now, if you are talking about the atoms, we have to calculate the total number of electrons to be accommodated over the different types of the elements. Like you can just see at the number first, hydrogen has got the number of proton 1, electron 1, and there is no neutron. And in helium, that is it is represented by He, and it has number of proton 2, number of electron 2, and number of neutron 2. These are the these are the different types of the atoms which we can learn. So it can be we are just talking about the electron configuration. Just I want to urge you that you can calculate the electronic configuration of different types of the atoms up to atomic number 20. That means hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, as well as sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and the calcium. You can just see your book, and you can just do the electronic configuration of these atoms yourself in your own copy. Now we are going to talk about the atomic structure of some elements, like this is how many electrons are being revolved around are you finding at the orbit? So 2. That means what is the name of this element? If there are 2 electrons, just you have just read there are 2 electrons at the helium. So by looking the structure also, you should have got the skill to identify the element also. That means it has got 2 electrons at the orbit and 2 protons as well as 2 electrons. So what is the name of this element? Yes, this is helium, because by knowing the number of electrons that has been found about in the first cell, so it is all about the helium. And this one, first of all, you have to count total number of electrons. In the first cell, you are looking 2 electrons. At the second cell, you are looking 1, 2, 3, 4, 5, 6, 7, and 8. So altogether, how many electrons are you looking there? Yes, total number of electrons present over this atom is 10. So if there are 10 electrons, which atom does this represent? Yes, it is about neon. Likewise, we can talk about the another atom also. You can see another structure of atom also. That is, first you have to count the total number of electrons present over the first cell, at the second cell, and the third cell, and you have to count. You have to add all of the electrons found over this structure. Then you will get total number of electrons. By knowing the total number of electrons, then you can just talk about the respective atom. So just count. At the first cell, you are looking 2 electrons. At the second cell, obviously there will be 8 electrons. Then at the first as well as at the second cell, just I think you have calculated altogether 10. At the third one, 1, 2, 3, 4, 5, 6, and 7. So altogether 10 plus 7. So what is the total number of electrons that has been present over this atom? Yeah, there are altogether 17. If the atom has the 17 electrons, then what is the name of this atom? Yes, good. You are talking about the same atom, that is chlorine. This is the atom of chlorine. Yeah, good. So I am giving another task to you to discuss as well, to identify the atom also, that is the structure. This gives the structure. So how many electrons does the atom consist? Just count, and you can find the you should have got the skill to identify the respective atom. So at the first you are looking 2. At the second you are looking how many? 8, altogether 10. Then 1, 2, 3, 4, 5, 6, 7. So it also consists the same. So that means whether you have just talked about this is the chlorine. By the same, you can just find this is also consists the same number of electrons. That means it is also what? This is the atomic structure of chlorine. So as you are talking about the structure, so we have just configured the number of electrons at the different orbits. So what are these orbits called? First, K shell, L shell, M shell. By the same way, then we are talking about what is valence shell as well as valence electrons right now. So as you have just looked at the screen, that the outermost shell of the atom is called valence shell. So this is the first shell, this is the second shell, this is the third shell. First of all, you have to draw the structure of an atom. Then you can find the last orbit. You have to see the last orbit. the last orbit present over the atomic structure, that is called the valence shell or valence orbit, and the total number of present over this valence orbit or valence shell is called valence shell. Likewise, at this structure, at this atomic structure, you can see there is 2 electrons as well as 8 electrons in the second, as well as at the third they will be looking 13, 7. That means it has consist 7 electrons at the valence shell. So these 7 electrons present at the valence shell, they are called the valence electrons. So how many number of electrons do you find at the valence shell? Yes, 7. So these electrons which are found at the valence shell or outermost shell, they are called the valence electrons, and that shell which is located at the outermost part of the atomic structure, that is called valence shell. So I think in this first shell you are just looking 7 electrons as a valence electron. By the same way, how many electrons do you find at the second this structure? How many valence electrons are there in this structure? Just count 1, 2, 3, 4, 5, 6, 7 and 8. So altogether how many valence electrons do you find here? 8. Why these electrons are called valence electrons? Can you say? Yeah, because these electrons are present at the valence shell. Why this shell is called valence shell? Yeah, because this shell is present at the outermost orbit or outermost part of this atom. So this is all about valence shell as well as valence electrons. That means total number of electrons present in the valence shell, that is called valence electron, as well as the outermost orbit present over the atom is called the valence shell. Now we are going to talk about the another feature of the atom, that is called duplet state. Duplet state is the state of an atom in which the atom has got 2 electrons at the valence shell by either gaining the electrons or by losing the electrons. So by gaining or by acquiring 2 electrons at the shell, outermost shell, then the atom becomes stable, that means very inert, that means it does not want to react with other atoms. So in this condition, the atoms neither want to gain the electron nor the atom want to lose the electron. So this state or this gaining the 2 electrons at the valence shell, this state is called the stable state, or this is called the inert state. So in this state, the atoms does not want to do the reaction with other atoms. So in fact, or in conclusion, gaining 2 electrons by gaining the electron or by losing the electron, that is called the duplet state. You can just see the example, that is it is the atom of hydrogen, this is the atom of helium. Helium consists 2 electrons at the valence shell, so it is already in the duplet state because it has acquired or it has 2 electrons at this orbit. But in this hydrogen, it has consists only 1 electron. So this hydrogen, if it gains the electron and if it becomes or if it acquires 1 electron here, that means it will be 2 electrons at this orbit. So it also can attain or can acquire the duplet state also. By the same way, we can talk about the octet state also. That means the state of atom acquiring 8 electrons by gaining electron from other atoms or by losing the surplus electrons, either they have got 1 electron or 2 electron at their valence shell. If they acquire 8 electrons at the valence shell, they are called the octet state, and the gaining 8 electrons or acquiring 8 electrons at its valence shell, this is a rule which is also known as octet rule also. So K cell can acquire duplet state, but L cell, M cell as well as N cell, they can acquire octet states. So this acquirement or this attainment of the such electrons in different energy levels, that like L, M as well as N as well as K also, it can be calculated by 2n square formula, which we have just discussed in our earlier pages, part. So this state, that is acquiring 8 electrons at its valence shell, that is called the octet state. So if an atom acquires the octet state, this atom neither wants to gain the electron nor it wants to lose the electron. That means, so it does not want to react with other atoms. So it is called the stable state or It is also known as the inert state of an atom. So you can just see over these structures, atomic structures, like this is one structure. It is, you can just see there are altogether how many electrons do you find at the valence shell of this atom? Just you count 1, 2, 3, 4, 5, 6, 7 and 8. How many electrons does this atom has at the valence shell? Yeah, altogether 8. That means it consists 8 electrons. So it is in the octet state. In this state, this atom, just you are looking in this structure, this atom neither it wants to gain the electron nor it wants to lose the electron, because it is already in the satisfied or saturated state. That means in L cell can acquire or accommodate only 8 electrons. If this L cell does not accommodate more than 8 electrons, then if it has got 8 electrons at its valence shell, obviously it is already satisfied as well as saturated. So it cannot accommodate more than 8 electrons. So it is called the stable state. So this stable state is due to the octet state. So this is called the octet state, or this atom has acquired the octet state. Likewise, if you count total number of electrons present over the valence shell, 2, 2 as well as 2 and the 2. Altogether, how many electrons does it have at the valence shell? Yes, good. It has got 8 electrons. So it is also in the octet state. So in such states, atoms are not reactive. They do not want to do the reactions. So this state of atom are called the inert state or stable state. So if the atoms are in octet or duplet states, they can be considered as the stable state. You can just see other examples also. If you count the total number of electrons, like 1, 2, 3, 4, 5, 6, 7, 8, it is also in octet state. 1, 2, 3, 4, 5, 6, 7, 8. In this atom also you are looking 8 electrons at the valence shell. So it is also in the octet state. And by the same way, if you count the total number of electrons present over this element, that is xenon, so you will find altogether 8 electrons. So like just you count 1, 2, 3, 4, 5, 6, 7 and 8. So all of these atoms that you are looking over the screen, they are in the octet states. So they are considered as the inert elements or atom of inert elements. Now we are discussing about some questions related to the atomic structure as well as octet rule as well as electronic configuration. Just we have discussed. So just read the questions present over this screen. That is, according to the atomic structure given aside, just you can read the structure, just analyze the structure. Which of the following statement is true? Then you have to find which of the statement that follows will be the correct one. The first statement given over the about the atomic structure given aside is, this is atomic structure of sodium. Is it true? Try to evaluate, try to find the correct answer. And the second, you are getting one statement, that is, L cell of this atom has 2 electrons as well as K cell consists 8 electrons. Is it true or not? You should have got judging power over this. And next one, it shows the duplet state. Then just what is duplet state? We have just discussed whether it is in the duplet state or not. You have to find the correct answer. At the fourth statement, it states that K cell consists 2 electrons as well as L cell consists 8 electrons. Is it true? Yeah, please. Out of these 4 alternatives, which one is the correct one about the structure given aside? Have you got the correct answer or not? Have you reached in the conclusion? Yeah, okay. Yes, you are thinking. The correct answer is D. That means K cell of this atom has 2 electrons as well as L cell consists 8 electrons. Now we are talking about another question. So the question is, which of the following electronic configuration is correct? The electronic configuration given are, at the first one, K cell consists 2 electrons, L cell consists 5 electrons as well as M cell consists 7 electrons. Is this correct or not? Yes, you do have got a final answer with you. And in the B, K cell consists 2 electrons, L cell consists 8 electrons as well as M cell consists 4 electrons. Is it correct? Yeah, okay, we will talk, we will conclude at last. And in the option number C, there is 2 electrons at the K shell, 7 electrons at the L shell, as well as 5 electrons at the M shell. Is it correct or not? As well as in the D, 2 electrons at the L shell, sorry, K shell, and 4 electrons at the L shell, and 8 electrons at the M shell. Out of these all 4 electronic configurations, which one is the correct electronic configuration? Yeah, exactly. This is the correct answer. That means, first of all, why this is the correct answer? Because this has got, first of all, this orbit should be filled, and L orbit, first of all, K orbit should be filled, and L, as well as after filling the second orbit, the electrons will be kept at the third orbit. Without filling this one or second orbit, we cannot put, or we cannot keep the electron for the third one. So if you see here, because in the second orbit that can have got the 8 electrons, but it has written only 5, so it is incorrect. In the C also, at the K shell there is 2 electrons, but in the L shell there is 7 electrons, but L shell should have got 8 electrons, because we do have got more other electrons also, so it is also the incorrect one. In the D also, in the second orbit there must be 8 electrons. So this is the, or B is the correct answer over this question. Now by the same way, we can discuss about another question, that is, what is the average diameter of the n atom? It just you have seen at the first one, that is 10 to the power minus 10 meter is the diameter, approximate diameter of an atom. So this is the correct answer. And in the 4, how many electron or electrons does the structure need to gain duplet state? So you can just see this structure here. So how many electrons does it need to acquire the duplet state? That means to acquire 2 electrons at the valence shell, how many electrons does it need? Because already it has got already 1 electron. If this atom gains 1 more electron, obviously it gains the duplet state. So this should be your explanation. I think you have written in your written answer in your copy. Now we are talking about another question, that is fill the following information in the given table, or K table has given here. That means serial number has 1, 2, 3, 4 and so on. We can put some other elements also, and name of the elements are sodium, phosphorus, chlorine and calcium. Then number of electrons present over this. First of all, you have to find the atomic number, and according to the atomic number you can write the total number of electrons present over the respective atom. Like sodium has 11 electrons, phosphorus has 15 electrons, chlorine has 17 electrons, as well as calcium has 20 electrons. So these electrons should be configured in different orbits by using 2n square formula. Then you can put the different types of the electronic configurations of this type of elements in your own copy. I hope you can do this yourself. Now I'm at the last part of my today's class. I want to talk about I want to give some project works for you. Make a model of oxygen atom by the help of string and tennis ball. You can just, I'm giving some helpline for you to do your project work or to complete your project work. First you have to take a string. First you have to take one string, then you have to just bind these strings like this. Then you should have got some tennis balls, then just make hole over the tennis balls. Then how many electrons does the oxygen have? Altogether it has got 8 electrons. So first you have to write 2 electrons. You should have got 2 strings. So at the first string you should have got 2 electrons. You have to just put 2 tennis balls over the first one. Then you can you can just take 6 more tennis balls. Then you can make some other balls as to make its nucleus. You can just put here. Then just you can use glues as well as dendrites to just bind them over there. So you can have got 8 protons as well as the 8 neutrons. To make 8 protons as well as 8 neutrons, you should have got other materials also, so that you can make the nucleus. This is the nucleus. Then these are the orbits. So by the same way you can do this project work. At the second, you have got one more project code, that is make a chart of atoms of the elements from atomic number 1 to 20 according to the example. just I'm giving some guideline for you to complete your project work. Like there are, you should have make such tables, that is serial number has there, you have to make up to 20 here, and you have to write the name of the elements like hydrogen, helium, lithium, and so on up to calcium. And you need to write the symbols of these elements up to 20, that is H, He, Li, and so on up to Ca. And you should have got the skill to do electronic configuration of these elements. How many electrons does the hydrogen have at the K shell and L shell as well as M shell or N shell? If it has got only one electron, then it can be accommodated, or it can be kept at only the K shell, and helium also in the K shell only, and lithium only K shell accommodates only 2 electrons here. Then one more electron is left after filling up to the K shell, then you can write 1 electron over this L shell. By the same way, you can complete this table and you can submit your teacher. Dear students, I think you in my today's class you have enjoyed a lot, as well as I think you have got a bit more that interesting knowledges about the atom and atomic structure, as well as how to say the state of the atom is duplet or octet, and how to configure the electrons in the various orbits. I hope you have got these things in my today's class, and you have enjoyed all it. I want to conclude my today's class. Thank you very much.